So we're at our very last section in the course, which is section 3.8. This is about transforming graphs of functions. Transforming graphs of functions. So the idea is that we're going to start off with some function. Let's call it y equals f of x. We're going to call this our parent function. Our parent function, y equals f of x. And you have two positive numbers, h and k. I'm going to call h blue and k red. And let's see here. We want to look how to make new functions from our parent function. So the first new function we're going to focus on is this f of x plus k function. I want to show you how this is a transformation of the original parent function. So let's say you have your parent function y equals f of x, right? This is your parent function. And you take some point here. So the input we call what? X. And the output, the y value here. The y value here is what? F of x. And then let's say I have another function. This new function, the red one we had earlier, f of x plus k. F of x plus k. How does that differ? Well, you got that plus k, right? Plus k outside of the house. So the input is still, if you think about the input's still x. But this time the output's different, right? The output's f of x plus k, so that's just going to move everything up k. So you're going to have f of x plus k up here as your output. So that green point basically got shifted up, right? Still the same x value. Still the same x value. But this time a different y value, f of x plus k. So I mean, if you take any other green point, let's say I had a green point over here. That's supposed to be green. That's going to get shifted up k as well, right? It's going to move up like to maybe here or something. So basically all the green points are going to get lifted up by k units, so everything's going to shift up by k units. So I described that in my my table here, right? If I take f of x plus k, I add k outside of the house. That what? Adds k to all the original y coordinates. That shifts your graph up by k. Similarly, that's going to happen with a minus k. When you have a minus k, minus a number outside of the house, you're going to subtract k from all your original y coordinates, and you're going to shift down k units. Now, let me just do an example of that real quick. A real example. Sketch the graph of the function using transformations. Let's say I had a number 1. Y equals x squared plus 1. So let's start by thinking about what is our parent function here. What's our parent function? Y equals x squared. Right, that's our parent function. So basically, if you cover up this this plus 1 right here, you can see your parent function is y equals x squared. So you got what? Y equals x squared plus 1. Now, how do we graph y equals x squared? Let's recall how to graph y equals x squared. Well, that's not good. So back when we were studying two-variable equations, this was one of 4 two-variable equations that I said you must be familiar with. Right, if you want to go back and you want to make a table of values to remember, you can. Just take what? -2, -1, 0, 1, and 2. and you're plugging those in for x, and you square negative 2, right? You get 4, you square negative 1, you get 1, you square 0, you get 0, you square 1, you get 1, you square 2, you get 4. If you plot those points, so I said there are 5 key points you need to know. Negative 2, 4, that's your first coordinate, or set of coordinates. Second set of coordinates is negative 1, 1, then 0, 0, that's the third set, then 1, 1 is the fourth set, and the fifth set's 2, 4. So, I mean, eventually you just memorize these points. So there's our parent, right? Our parents. Now that was not good, was it? My graph just disappeared. Let's try this one more time. We had a point there at 0, 0. And this is supposed to form what's called a parabola, right? A nice U-shaped parabola. Now, I'm interested in what? Y equals x squared plus 1, right? So this is going to, the parent is shifted up 1, is shifted up 1 unit. Why? Because we have a plus 1 outside of the house there. So we're going to take all our points and shift them up 1 unit. So I'm going to take my green point here on the right and move it up 1. I'm going to take my next green point at 1, 1 and move it up 1. I'm going to take 0, 0, I'm going to move it up 1. I'm going to take negative 1, 1 and move it up 1. And negative 2, 1 and move it up 1. So everything gets shifted up 1. And we're just going to connect our dots into a parabola. So that's our red graph. I'm actually going to put, that was just, I guess you can say, practice. I'm going to put this over here to the side for a final graph all by itself, separated. You don't have to do this. You can put them on the same. But I'm going to do this all by itself. Separate, so we can display it in its glory. So here we have what? We have negative 2, 5. Put that out here to the side. We have negative 1, 3. No, sorry, negative 1, 2, actually. What else? We have 0, 1. We have what? 1, 2. We have 3, 5. Try to draw this as neat as I can with this setup. This is going to be y equals x squared plus 1. So this is our final graph here in the box. All right, let's do another example. Let's say we have what? Y equals x cubed minus 2. So if you look at your parent graph here, if you cover up this this minus 2 right here, you just have what? Y equals x cubed. So remember, that's a very important graph. Y equals x cubed. Right, if I did a table of values, remember this is another one you should be familiar with. You should know the points. I can plug in what? Negative 2, negative 1, 0, 1, and 2. Negative 2 cubed is negative 8. Negative 1 cubed is negative 1. 0 cubed is 0. 1 cubed is 1. 2 cubed is 8. You can plot these. x-axis and a y-axis. One, two, three, four, five, six, seven, eight. 1, 2, 3, 4, 5. Six, 7, 8. It's -8 down there. So plotting my key points, I'm going to start with -2, -8 here. Then what? -1, -1, then 0, 0, then 1, 1, and finally 2, 8. Before I put 2, 8, I want to make sure I connect these. That's not too straight, is it? Let me try to make this a little more. Hard to do it with this setup. Let's see. There we go. And then 2, 8. There it is. That's y equals x cubed. Now, what are we doing? What about y equals x cubed minus 2? Y equals x cubed minus 2. This shifts the parent down 2 units, right? Because you have a -2 outside of the house, you're going to shift the parent down 2 units. So basically, we're going to take every point and move it down 2. So I'm going to take that 2, 8 and move it down here to 2, 6. I'm going to take 1, 1 and move it down to 1, -1. I'm going to take 0, 2, and I'm sorry, 0, 0 and move it down to 0, -2. I'm going to take -1, -1 and move it down to -1, -3. And I'm going to take this point here, -2, -8, and move it down to -2, -10. If I connect these points appropriately, so thinking about where this central point is, this is actually called the inflection point. It's going to curl upwards here. Well, and then below that inflection point, it's called the inflection point. It's at the center. It's going to curl downwards. So there it is. That is y equals x cubed minus 2. Now I'm going to give it its own graph off to the side. I wish I could zoom out. It would be nice if I could zoom out, because everything's not really fitting all in here like I would like. One of the limitations of this platform. Yeah, come on, it's not writing. Please write. There it goes. So here's my central red point right there. Well, that's supposed to be red. Didn't turn red. And I got this point here, and then I got this point here. All right, let's see if I can get this to work. One, 2, 3, 4, 5, 6. Yeah, there it goes. There we go. And then down here. Go down to -10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's -10. So we have what? -2 on the x and -10 on the y. There it is. Y equals x cubed minus 8. There's our final graph right there in red. Yeah, it won't all fit on this screen, unfortunately.